Hey guys, and welcome back to another YouTube video. So in this videos I will be teaching you how to create Frogger using Python. So it will be not like exactly a Frogger clone. It will be somewhat like Frogger, so you will be able to recognize it, but it won't be a complete clone. So as you can see over here, I've just created this new folder called Frogger game, and I have these few assets over here. Now all of these assets will be available for download with the link to a GitHub repository in the description. One thing that I want to say before I start out is I think a few of these assets have been taken from a few YouTubers. So actually shout outs to them. So like this idea has been taken from Tokyo Attack. So shout outs to him. The code is completely different. It's mine, but like the idea has been taken from him. So we will actually be using Pygame, and he had actually used Turtle to do this. So first of all, what I want you to do is open up your terminal or whatever you are using, Windows, Mac, or Linux. If you are using Windows, you will open up your command prompt or PowerShell, and you will be in your root directory. So in this case, this is my root directory. If you are on Bash, it will be a bit different. Since I'm using ZSH, it's a bit different. So first of all, that you want to do, what you want to do is just about pip3 install pygame. This is the command that you want to run, and then you just want to click on enter, and it will go, and for me it's saying requirement already satisfied, but because I've already installed this module, but for you it should go and actually install pygame, which is the module that we will be using to actually create this game. So alright, so I've opened up this main.py file, and first of all we just have import pygame. So this is the line to actually bring in pygame to our Python code. Also, just one thing, we will be using classes and objects. So if you we will be using these good practices for our code. It won't be the cleanest, but it will be something good. Now we need to import a few more modules, but I think we can do that when the time comes. So now we need to initialize pygame. Now to initialize pygame, we just type out pygame.init, and now we can go over and make the display. So making the display, to do that we just type out screen or any other variable. In my case I'm typing out screen is equals to pygame. Let me just dot set underscore mode, and then you need to pass it a tuple of the width and the height. So we can now go over and actually define the game variables, which will be the width. In this case we will just make it like 500, and the height of the screen, which will be like 750, I guess. I think we will bump it up to 800. Now one thing before you specify the height is actually monitor based. So if you actually if I actually show it to you over here, if I go to displays, as you can see over here, it is showing my display is actually kind of close to 4K, like it's 2K. So what the thing is that I have a ton of pixels in my screen, and if you are using like an older computer which is like 1080p or something, then your pixels and all of them are not really going to be able to accommodate such a big screen. So you might want to play around a bit with the screen sizes, but if you are using a Mac, you probably will be using these screen sizes unless you are using some really old version. So now what we do is we set a caption of the screen. So we just have a pygame.display.set underscore caption, and I will just call it Frogger game. And now we will code in the main game loop for our game, because let me actually show you something. If I head on to my terminal and I cd to my directory, I will be running it through my terminal, in case if you want to just have a check at it. So I will just run an ls to see if I am in the correct directory. So if I see all of the files, that means I am in the correct directory. So now I will just run python 3 main.py, that's the name of the script, and you can see it will show these stuff, and as soon as the window pops up it will disappear, and the reason is it will execute this much of the code and it will then just completely break out. So we will code out the main game loop. So let's code out the main game loop. What we do is just about running equals to true, and while the game is running we want to check for our event. So for event in, pygame dot event dot get. So we get all of the events, and if the event dot type is equal to pygame dot quit. So if I click on the this red button, or in the Windows it will be the cross button, then we want to stop the game from running. So we simply say running equals to false, and we also want to update our display. So we just about update the display by just typing out pygame dot display dot update. And one last thing, we actually also want to fill our display. So I will just define a color black. Now this has to be an RGB code, so that's why we are saying black is 000, and white will be 250 by 250 by 255. Just a thing. So fill the screen. So screen dot fill the color black. Now we will actually run this program and see how does it work. So python main.py, and there we go, it says Frogger game, and we have this. Now this is like a really thin display, so I'm just gonna bump up the thickness a bit. So I will change the width to something like 600 and probably change this to 800. Now in my case 800 will be fine, but in your case, if you have a bad monitor, then you might want to keep it down a bit. So okay, now this is something good. This looks nice, so I will be using this one. So I'm just gonna shut it, and now let's just go ahead and create the player. So making the player class. Now we will be using classes and objects to create this program. So we will be using a player class, we'll be using an enemy class and everything like that. So class player. Now we could use inheritance to make this a bit easier, but I think for the course of this video I will not be using inheritance. So it will be self.x and self.y. I think those are the two attributes that we will actually be caring about the player. So self.x is equals to x, and I don't know why this is happening. Okay, self.y equals y. And now we actually need to make a function inside of our player class that actually draws our player to the screen. Now drawing the player is actually really simple. Pygame is really good at all of that. So I will just have this function called draw, which will take in the self and the surface. Now if you don't know what the surface is basically the kind of like the screen where the entire player will be drawn. So I'll just call image is equals to pygame dot image dot load. So you will load in an image. Now the image should be kind of like in the same directory. You could specify a different directory by using os.path.join, but for that what you would need to do is you need to import os into your Python game. So we will be using the frog.png file. So this png file. Now this is a 64 by 64. So in case if you are downloading anything, download a 64 by 64 file. So we simply will load that in. So I will just type out frog.png, and we can just type out surface.blit. Now blit will kind of like that display this image, and the coordinates will be self.x and self.y. Now we will be making the player objects. So making the player objects. So player will be equal to, actually I think this should be frog, since frogger is based on a frog. Pretty self-explanatory. So for now I'll just put him in the center, and later on we will actually work on positioning him. So the center will be 300 by 400, and now we actually let me just run the program and show you what happens. So you will see that there will be no frog on the screen. As you can see, there is no frog. Where is the frog? Even though it should be somewhere over here. Well, the reason is we have only made the draw function, but we haven't never called it on the player. So let's just call it. So we will call it in the main game loop because we want to draw him continuously for every frame. So you just type out player.draw and on the screen, right? Because we want to draw him on the surface, which is the screen over here as we know it. So let me run this file again, and there we go, we have this frog. And now you can use some any other frog. I decided to go with this one, but it's up to you. So I'll just close this. Now we have written the player class, incomplete. It's still incomplete. We still need to deal with a little bit. So let's actually deal with the player movements. Now, since Frogger was actually a retro game, it was one of the arcade games. It was a little bit old. So the movement wasn't based on like the pixel perfect, very silky movement. It was actually block based movement. So it would be like a specific direction of like 15 pixels or 20 pixels. So to keep with that vibe, and even we will have that blocky movement in our game. So but if you don't want that blocky movement, check out my other pie game videos where I actually am doing this smooth movement, so you can use that also. So if event dot type is equals to pie game dot key down, so when any key is down, any key is pressed, we check if the event dot key is equals to pie game dot k underscore right. So if we are clicking our right arrow key, then what we want to do is we want to just say player dot x, and this player, and we will get the x position, and we will just go plus equals 20. So as you can see, if I click on the right arrow key, we move our frog, which is our player. And let's just do the same thing for the left. So if event dot key is equals to pie game dot k underscore left, if I'm clicking on a left arrow key, what I want to do is just type a player dot x minus equals to 20, since we are going towards the 0th coordinate and not towards a width coordinate, which is 600. So that's something that you need to take into account. So now if I click on my left arrow key, the player will move in left, and if I click on my right arrow key, the player will move right. Alright, so I'll just clear this terminal screen. Alright, so now we will do that up and down movement. It's pretty simple, it's pretty much the same thing. So if event dot key is equals to pie game dot k underscore down, down, we want to do player dot y this time, since we are dealing in the y coordinate, plus equals 20, since down will be the maximum coordinate. And if the play event dot key is equals to pie game dot k underscore up, so if we are clicking on the up arrow key, we just want to do player dot y minus equals to 20. So this should wrap up our key binds, key movements, and it has. So we have this really cool player who can move. Awesome. So now we actually need to do the boundary checking, because right now we can actually move our player outside of the screen and there are no problems in that. Now we actually want that the player should halt whenever it reaches this coordinate, and this in this case is the 0th coordinate, and this is the 600th coordinate, like here. So in the pie game, this will be 0 0, this will be the maximum. Alright, so border checking is actually really simple. It doesn't really take that much of time. So boundary checking, so here we will have all of our code related to that. So if the player dot x is lesser than or equal to 0, then I want to set the player dot x to 0. And one more thing, if the player dot y is lesser than or equal to 0, I want to set the player dot y equals to 0. So now if I run the program, you will see something. So if I run this, we have a boundary checking for the left hand side. So as you can see, even if I'm clicking the left hand key, it won't work. And even if I'm sorry, it will be for the left hand the top and not for the left hand the bottom. I by mistake got like carried away, and I just did it for the bottom. Alright, so as you can see, we cannot go like outside the screen in the left hand side, but we can go like from the bottom and from the right, and we also cannot go from the top. So that's something that we like. So yeah, so now what I will do is actually work on the collisions for the right and the bottom. Now those are a little bit tricky, since the thing is 0 can allow us to do everything really nicely, since the thing is everything below 0 will be negative, so we can just use this. But the thing is, all of these players are 64 by 64. Now if you will actually zoom into the players, I don't think I'll be able to do that. Okay, I think I cannot. Now you will see we have this boundary box around each of the players, and So instead of assuming that the player will be 64, uh, we assume that the player is 70, and that allows us to do some actual really good boundary check. So if the player dot x is greater than, now I will use some smart logic here. The thing is, we are the current width of our screen is 600, right? Now I don't want that the people who are working on a bad display to actually change their code, because otherwise they will have to change their code to the width. So what we will do is we will actually access this width variable in the boundary checking, and we will do some smart work. It's not like that smart, but it's a cool trick. So width minus 70. So if that's the case, you want to set the layer.x equals to the width minus 70. I tried this out in another one of my projects. Let's see if this one works in here. So I will run the Python script, and well, as you can see, it has worked perfectly, and we have some really accurate boundary checking going on over here. So I'm really happy that it worked. So now let me just actually position the player kind of like downwards, because otherwise it's pretty bad. So the x position will be the same. It will be the y position that will change. So currently the height is 800. So this will be positioned at 730. So 70 pixels down. So let me actually try this out. And there we go. It is working like a charm. So now time for the Y movement. Now even that is pretty simple with the trick that we have come up with. So if player dot y is greater than height minus 70, you want to set a player dot y to a height minus 70. So that's really cool. And yeah, it's working. Now just to actually understand what this 70 means, if some other guy opens up a code, I will just define it over here, because I really don't like such magic numbers popping up in my code, like why have I chosen 70. So make this variable called approximate underscore player underscore dimensions is equals to 70, and I will copy that. Now since this is a constant, it should be capitalized. Like, you won't get a syntax error if you don't, but it's a really good practice if you do. Alright, and now let me just run this again just to see if it works and nothing has broken, because a lot of the times that can be the case. So now you can see we have some really good boundary checking going on in our game, and it is just really good. So we have done quite a bit of code today, but I still think we could create the enemy class also today. We probably won't do the enemy objects, since the thing is Frogger, even though it's a small game, I think this game will at least require about 300 lines of code. So we at least will have to write like some amount of code, and I probably don't think we will be able to do it in like a single video, because if you will have a look at it, we still have been programming for like about 20 minutes now, and a lot of the times, a lot of the long videos don't actually have a good watch time, so people don't actually watch. But if it's a short video, everyone watches it, and everyone will get more information out of it. So just for the sake of it, I will create the enemy classes just as a template, so we can actually use it and continue it in our second video. So that's why. So making the car class. So I will have a class car, and I will have a define underscore net underscore self x and y, and I will just say self.x equals x, self.y equals y. And now let me actually show you something. So let me actually open up Google Chrome, and let me actually show you how Frogger looks, because we will see something pretty important in there which I think you will need to know when we actually write the code for a car class. So let me actually show you that, so you guys can have a better understanding of why we are going to do what we are going to do. So I'll just search up Frogger images. I will just search for that. And yeah, I think this image is a good one. So if I actually go over here, alright, if I actually go over here, so you can see we have these cars, all of which are traveling in the different directions. Now what we could do is we could have a separate class for the right car and the left car, but as we know it will take up a lot of code. So what we will do is we will have the same car class, but instead of even inheriting, you will have multiple different functions inside of the car class, and for the right car and the left car. So that's how we will be doing. And also I think we will need one more thing called the x underscore change, which you will look at like later. Change is equals to x underscore change, and I'll have a few methods in here. So draw underscore right underscore car, and that will take in self and the surface. For now I'm just passing all of these methods. Def draw underscore left underscore car self surface pass. We will need def drive underscore right self actually I think I actually just realized, instead of actually doing this, I think it will be actually better if we do it in two classes, because it will actually help us to do some things which otherwise would actually be a bit more difficult. So I think I'm gonna do it like way. So I will just have this thing called right car. So right car will be this car. So the car.png. I'm sorry, that will be the left car. This will be the right car. The baby car.png. Alright, so we have the def draw and drive, and I will have this thing called def check underscore boundary self pass, and we will have kind of like these same functions for the left car. So making the left car class, and I'm just going to say right car class. I'm just going to copy these. I'll just copy these and I'll just paste it right over here, and instead of right car this will be named as left car. And that is it. That is the code that we are writing for today. It's still like 100 lines, so that's a little bit to soak in. I know it's exactly 100 lines, so that's a little bit that you have to absorb in this video. Just one last thing, it's just 2 lines of code, but it's pretty cool. So let's just have an icon for our screen. So let's just keep the frog as the icon. I think it will look really cool. So set the display icon. So icon, so we just type out icon is equals to pygame.image dot load, and I will just go frog.png, and we can just say pygame.display dot set icon to icon, and I will run the script over here again. And if I go over here, we get Python 3 with this frog logo. So now we have this frog, and like if you are in Windows it will show it over here also, but if you are on Mac or Linux this will be how it happens. So yeah, so that's that. So that's pretty cool. Like we can have it a little bit more personalized. You can have whatever you want. I'm just keeping it a simple frog. So yeah, so that's it for today guys. I hope that you enjoyed this video. All of the code, everything will be available in the description down below. Mainly all of the downloadable material, not the code for this video, but all of the downloadable material will actually be available. So if you want to use these assets you will be able to do that. So I know that has been a little bit of a while, but I was pretty busy these days. So yeah, and now I will actually be back to making a lot of videos these days. because I have my vacations coming up in a few days, so that will be really good. So I will be able to make a lot of more videos and probably a lot of more streams actually, and I probably will be doing them for actually quite long, probably go for like a few hours straight. That will be something really good. So that's it for today, guys. I hope that you enjoyed the video. If you did, like and subscribe to the channel, and I will see you in another YouTube video.